Hello friends, today I'm gonna talk about theory. I like to do experiments, but today I'm gonna talk about theoretical questions. I wanna talk about Maxwell equation. So, Maxwell equation. I don't know at what level your country requires knowledge. I studied physics in Latvia myself, but now I work as an engineer in Russia. And I don't know the requirements of your educational institution for the Maxwell equation, but if you come across it on the exam, you should tell something like this, so that a picky teacher does not bombard you with unnecessary question, it seems to me. So, Maxwell equation, they can be written in integral and differential form. I prefer in differential form to divergence and rotor. It seems easier to me. So, the first Maxwell equation. This is first Maxwell equation. I'll write now. Divergence D is equal rho. This is the Ostagradsky-Gauss theorem in differential form. The power of the drain of the vector field of the electric displacement vector is equal to volumetric density of free electric charges. Rho is not the density of matter. Remember this. Rho is not density of matter. Rho is the volumetric density of free electric charges. Don't confuse it. You can also write a connection, and it needs to be written how the electric displacement vector is connected to the electric field strength vector. I do now. D is equal epsilon 0 E. In Russian English E, in English E, A, B, C, D, E. So it's simple. We simply take into account the property of the dielectric, epsilon, and the boundary effect at the boundary of, for example, different media, so we write using the electric displacement vector. This was Maxwell's first equation. Now the second Maxwell equation. Second. Divergence B is equal 0. It means that the magnetic field lines are closed and the magnetic charges do not exist. I repeat this. Magnetic field lines are closed and the magnetic charge do not exist. There is no need to say anything more about the second Maxwell equation. The third Maxwell equation. Rotor E, rotor E in English, E in Russian, rotor E in English, is equal minus dB per dt. This is nothing more than Faraday's law of electromagnetic induction in differential form. Rotor E is an EMF, electromagnetic force. In this case, this is no longer the electrical intensity that was in Maxwell's first equation. Here is the intensity of the vortex electric field. Vortex field, simple electrostatic field. Vortex field in this case, in this place, first Maxwell equation, electrostatic, strange, electrostatic field and vortex field. Don't confuse. And that's it. Maxwell's last equation, 4. It's given to the rotor of the magnetic field strength. Rotor H is equal G factor plus, I'll write epsilon 0 dE per dt. It can be said that a vortex magnetic field is caused by conduction currents and a time variable and vortex electric field. This is very important. the derivative of the electrical intensity vector in time, it also called the displacement current. But it is better not to talk about it. It is better to say that this time varying electric field creates a vortex magnetic field. Do not make sure that you are asking questions that you do not need during the exam. Remember that these four equations contain electricity and complement the theory of electromagnetic wave propagation that Maxwell predicted in equation 3 and 4. That's all for now. Thanks for watching me. Yuri Kovalyonok was with you. I'll write what is G, current density. And in this place probably you need to talk about electromotive force, EMF. Yes, I write down. Sorry for my English. EMF. This is EMF, electromotive force of EMF. I write. I hope you know what is this EMF. So magnetic field is vortex. You write approximately B vector. And in literature, this case probably write something like dd per dt, but more better if you write like I to do. That's all. Bye bye. Yuri Kovalyonok was with you. Thanks for watching me.